Good day, learners. Welcome to Technical Mathematics lesson. My name is Mathule Latakomu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Grade 11 learners, our topic of today is equations and inequalities, and we are going to look into quadratic, inequalities, and simultaneous equations. Let's look at our lesson objectives. At the end of this lesson, learners should be able to solve quadratic inequalities and interpret solutions graphically. That is important. Quadratic inequalities and interpreting the solutions graphically. Then the second one is learners should be able to solving equations with two unknown variables, which is what we call simultaneous equations, where you have two variables. So those are our lesson objectives. Looking at quadratic inequalities, let's check quadratic symbols and how to understand them. Then we have the first one, where we all know that if you see a symbol like this one here, you are going to say it's less than. Then you can say it's less than or smaller than, correct? And when you indicate it graphically, you are going to put a open circle there, correct? Then you are going to look into the second symbol. The second symbol is greater. It's greater than, correct? And then also when you are representing it graphically, you are going to also use an open circle. So now, what does it mean when it says it's an open circle? It means the number that you are talking about there is not included, but I will make an example on that one so that we can understand it. Then we have the next symbol there, which is less than or equal to. Remember, it's less than or equal to. That line there, it represents the equal sign, correct? So that's why we're saying it's less than or equal to. And when you represent it graphically, you are going to indicate it with a shaded circle. Then we go to the next one. We have the greater or equal to. And then when you represent it with when you present it graphically, you are going to shade that circle there. Then we have equal to. That's why equal to is saying it's an open, it's a shaded circle there. So those are the symbols that we are going to look into when we're dealing with quadratic inequalities. And please understand that whenever it doesn't have an equal, you open the circle. So now let's look into another important factor that we need to look into here. We're saying add or subtract to isolate the variables, the variable term. So when you multiply or divide to solve the variable, if multiply or divide by a negative number, then reverse the inequality symbol. So we can see that our value of x that we are looking for here is a negative number there. Then when we solve it, obviously you are going to transpose this 5, which is going to be negative 16, and negative 5 gives you negative 21. And as we are solving for x, we must divide both sides by 3. Hence you can see that 3 is dividing by negative 3. Then the minute you divide by negative 3, you reverse the inequality. So what does it mean? It means the inequality sign, it changes the direction. You can see at this moment here that it was less than or equal to. Then now, after dividing with a negative, it changed to greater or equal to. Then the answer here, it will be x is greater or equal to 7. So now those are the few things that you need to understand, especially when you divide by a negative number when we're dealing with inequalities. The inequality symbol will change the direction. So now, when I said we need to understand how do we deal with this inequality. Remember, we have greater than, less than, greater or equal to, and less than or equal to. So suppose that we are having x is greater than 3, correct? If we were to represent it on a number line, we are going to say 3, then because it's only greater than, it means 3 is not included, hence now we are doing what? We are putting our open circle there. Then it's greater, it will go to positive infinity because it will be 4, 5, 6, up until positive infinity. Those are the numbers that are greater than 3. But if ever we are given it in the form of x is greater or equal to 3, then when we represent it on a number line, we are going to say 3. Then now what will happen to our circle? It will be shaded. Our circle will be shaded. Then we indicate that is greater than 3. Because here it says greater or equal to 3, it means 3 is included. Hence we are shading it because 3 will be included. Correct? Then we can have another way where you write it as maybe 3 less than or equal to x. So this thing here, it still says 3 is less than or equal to x, which means x is greater or equal to 3. In this way, we're saying x is greater or equal to 3. Correct? Then we know that even when we write it in graphical form, we are going to use the very same graphic. So now we need to understand that whenever you have x greater than 7, and when you're saying 7 less than x, these things, they mean the same thing. So x is still greater than 7 and x is still greater than 7. So we need to know how to read these inequality signs. Correct? Then we move forward to our activity number 1, where we are going to solve for x and we represent the solutions graphically. So remember, when you represent the solutions graphically, it basically means that you must present your solution on a number line. So we have 4 sub-questions there. Then we're going to tackle them, all of them. So now, we're looking into the first one. We have x squared minus 3x minus 18 greater than 0. Correct. So what you do here before you solve this thing, always make sure that the leading coefficient, remember when I'm talking about the leading coefficient, we have ax squared plus minus bx plus minus c, which can be greater than 0. So the leading coefficient is the number in front of x squared. Always make sure that that number is positive so that we will be able to solve our inequalities properly without any confusion. Make sure that the leading coefficient is always positive. So now, the first thing that we must do here is to get what we call critical values. We must get what we call critical values. So for us to get critical values, because the leading coefficient is positive, it will be simpler for us where we have x squared minus 3x minus 18, then I can equate this to 0. Then what will happen here, I will simply factorize the 2. Remember, I'm not solving the quotient, I'm looking for the critical values. At this moment, I'm looking for critical values. So let's write our equal sign properly there. So now we're saying x and x, they will share those two brackets. Then now we start factorizing. Remember, as we factorize, the first thing that you look into is the sign of the last term. The sign of the last term is negative. Simply tells you that inside the bracket, I will have different signs. There is no way that the sign can be negative, then you have the very same sign inside the brackets. When the sign of the last term is negative, then inside the bracket, you are going to have different signs, because you know that positive multiplied by negative is negative. Then we're looking into the factors of 18. That can give you negative 3. The factors of 18 that can give you negative 3. Remember, the numbers that you multiply together and gives you 18, it can be 3 times 6. It can be 9 times 2. It can be 18 times 1. So those are all the numbers that when you multiply, they give you 18. So now, if you look into the first one, where we have 6 times 3. 6 times 3, when you multiply, they give you 18, and they can also give you 3 if you say 6 minus 3. So now, we are going to take the factors of 18, which is 6 and 3. Then we're looking into this case, we know that between 6 and 3, the bigger number will take the sign of the middle term, which is 6, and the smaller number is 3. Then from there, we know we apply what we call zero factor rule, where we solve for x there. So zero factor rule, it's x minus 6 is equal to 0. X minus 6 is equal to 0. So when you solve for x, x is equal to negative 3, or x is equal to 6. So those are critical values. We haven't solved or answered our question as yet. There we were calculating what we call critical values. And what do we do when we have to solve our question? Remember, we said that we must represent the solution on a number line. We must represent the solution on a number line. And then looking at our number line, we know that we have negative 3 and 6. So all the time you make sure that the smallest number comes on your left and the bigger number comes on your right. So the technique that all learners must know is that the minute you are having the two critical values, you can simply put your x in the middle. Then we look into the leading coefficient. Remember, we said the leading coefficient is positive. If the leading coefficient is positive, then you are going to use the inequality sign the way it is. You just put it inside those two numbers. So you have answered your question like that. So now, simply it tells us that the x is less than 3 and x is greater than 6. So we are going to say x that is less than 3 and x that is greater than 6. So that's how you are going to answer this graphically. That's how you answer and you show it graphically. That's what we are looking for. Remember, when we mark this type of a question, in grade 11, you might find that they're still going to give you 1 mark for the factors, 1 mark for critical values, and you have 2 marks there for your answer. Remember, your answer must always be in an inequality form. Your answer must always be in an inequality form. And I know that there are different ways of dealing with this, but we want to make it as easy as possible for the learners. So let's look into the next one and then apply the very same method that we have done here for better understanding. So looking at the second one now, we have to look for critical values, correct? Then the first thing that we need to do is to get our critical values. How do we get our critical values? We are going to have x minus 3, x minus 4 equal to 12. Remember, we are looking for our critical values. We can't use zero factor rule here because this equation now is equated to 12. So it must be always 0 on the right hand side. What we can do now is to expand our bracket. Then we're going to have x squared minus 4x minus 3x plus 12 is equal to 12. Then that's what we get there. Then now you are going to transpose this 12 to the left hand side. Then we're going to have x squared minus 7x plus 12 minus 12 is equal to 0. Then we add the like terms there. You can see that simply positive 12 and negative 12 will take each other out. Then we're going to have what? X squared minus 7x is equal to 0. Then from there we have two terms there. What can happen is to take out x as a common factor. X minus 7 is equal to 0. Then x will be equal to 0, or x minus 7 is going to be equal to 0. Therefore, x will be equal to 7. When you transpose to the right hand side, it will be positive. So this is how you solve these critical values. And remember, when you have arrived at the critical values, you haven't answered the question as yet. You haven't answered the question as yet. So now, how do we answer the question now? We represent our solutions on a number line. You represent our solutions on a number line. So we are having 0 and positive 7. So simply looking at this, after expanding, we're having a critical, our simplification equation like that. It can simply tell you that this equation, it can be written as x squared minus 7x greater or equal to 0. That's how you can write that equation after simplifying it. That's what you are going to get. So now, since that is the case, what we do, remember, we take x and we put it in the middle there. And then looking into this one, we can see that our leading coefficient there is positive. So if it's positive, then the sign of the inequality sign is the sign that you are going to use there. Then that's how you solve this type of questions. Correct? Then this is the answer that we are looking for in an inequality form. Then from there, what do? You then solve, you then represent the solution graphically. What do we do now? We are going to represent our solutions graphically, because now we're talking about greater or equal to. We are going to shade our circles. We're shading our circles because 0, it will be included, and also 7, it will be included. Then x is greater than 7, it goes that side. And x is less than 0, it goes to the left-hand side. So that's how basically we are going to solve that particular problem. So sometimes they will tell you that, okay, for you to decide on which values are going to be greater or equal to 0, one can say, okay, so now I was saying that one will explain this in a form of this manner. They will say you must substitute any number that is less than 0, which is maybe -1, and substitute the number between 0 and 7, which is maybe 3, and the number that is greater than 7, which is 8. Then they said you must substitute -1, 3, and 8 in the equation here, correct? And then that equation, if it's giving you positive, let's say now we substitute -1 there, then we are going to have what? We are going to have positive. Then if we substitute 3 squared is 9, and 3 times 7 is going to be negative, then this one is going to be negative, and then if you substitute 8, obviously it will give you positive. And remember, we are looking at greater or equal to. Greater or equal to, it means we're talking about positive numbers there. So at some point the teacher will explain it like that, but at the end of the day the answers are going to be the same. So now let's look into another sub-question where we better our understanding in this when we're doing it graphically. So now we have the question. It says x squared, it's less than or equal to 25. So now, first thing first, you must get your critical values. So if you have x squared, that is, okay, critical values, sorry, we said we will be equal to, critical values, we said it will be equal to 25. So we can transpose this 25 to the left hand side. Then we are going to have x squared minus 25 is equal to 0. Then we can see that there we can factorize by using different of 2 squares. Then we factorize using different of 2 squares. Then we're going to have 5 and 5. The one bracket will be positive, the other one will be negative. Then we use zero factor rule, x plus 5 is equal to 0, or x minus 5 is equal to 0. Then we know that x will be -5 or x will be +5. So remember, these are critical values. So now we are going to solve our equation. We're giving now our inequality form. So we have -5 and +5. -5 and +5. Then we go and apply our technique. We put x between the two numbers there. Then we check, okay, in this case, even if I can transpose this to the left hand side, you're going to have x squared minus 25 less than or equal to 0. And remember, numbers that are less than or equal to 0, they are negative numbers, correct? But because the leading coefficient there is positive, and I said always it needs to be positive, then we can do what? We can say, okay, the sign there is less than or equal to, then I will include the sign between the two numbers and x as what? As less than or equal to. Then that's how you solve your x there. Then remember, I said this is the statement that we want to see in a form of an inequality. Dealing with them graphically, because it's greater or equal to, they will be shaded. Both circles will be shaded because we are dealing with greater or equal to. So what do we do from there? We read x is greater than -5, x is greater than -5, and also x is less than 5, x is less than 5, then that's how you are going to show your solution graphically. So the part that I wanted to check, learners understand here, is that the minute your leading coefficient is positive, when you get to decide on your final answer, you just take the sign that is given there and you put it between -5 and x and +5. The very same sign will give you your solution. Like I said, the teacher, when they teach, they will tell learners to test it, to say give the number that is less than -5 is -6. Any number between -5 and 5 we can say is 2, and the other one is 6. Always it will give you that when you substitute -6 there, you are going to get a positive number, you get a negative number, and you also get a positive number there. But this one, it's less than or equal to. We're now looking into what? We're now looking into negative numbers. So negative numbers, you can see that they are between the interval of -5 and 5. That's why we're saying x is between -5 and 5, where we have negative numbers. So this type of questions, they are very easy and they carry marks. So learners need to understand how to deal with these inequalities. Okay? Then let's look at the last one in activity number 1, where we have x squared minus x less than 12. So the first thing that we can do there is to maybe put it in the standard form. We're going to have -12 less than 0. Then we can get our critical values. Critical values, remember, is x squared minus x minus 12 is equal to 0. Then we solve for x, but we start by factorizing. So we looking at the factors of 12, that can give you 1. So we said the factors of 12, remember, it can be 12 times 1, it can be 6 times 2, or 4 times 3. So when we say it gives us 1, it must give us the middle term, correct? So 12 times 1 is 12, but it can only give you 13 or 11, so that one is out. 6 times 2 is 12, but they can only give you 4 or 8, which is out. Then 3 times 4, they give you 12 when you multiply them, but when you add or subtract them, they can either give you 1 or 7. So I'm going to use 4 times 3. Then now we're saying the bigger number takes the sign of the middle term, then we are going to have negative and positive. Then from there, what do? We use zero factor rule, and x plus 3 is equal to 0. So as we transpose, we're going to have x is equal to 4 or x is equal to -3. Then from there, what do? We go and represent our solution graphically. Then we know that we have -3 and we also have 4 there. Then what do we say when we get here? We're saying, okay, I am going to put x there between the two numbers. And now the leading coefficient, because it's positive, then I can take that sign the way it is and put it between -3 and x and 4 there. So that's how you get your solution. Then representing it graphically, remember x is greater than 3 and x is less than 4. So we're talking about negative numbers there, correct? Because less than, it means you must look into the negative numbers there. So this type of questions, grade 11s, they always come when you are writing your exams, especially when they're saying you must solve for x. Always they will put an inequality and one equation containing an inequality symbol. So you should be able to solve this type of questions. So that's how now we deal with these quadratic inequalities. Only when the leading coefficient there is positive. So now in activity 2, we solve for x, and we also need to represent the solutions graphically. But the interesting part with this one is that now the leading coefficient is negative. Then remember we said you must always make sure that the leading coefficient is positive. So now we're looking at the first one now. It says 2x plus 3 greater or equal to x squared. So what will happen here is that we are going to take your x squared and we transpose it. Then it's going to have negative x squared plus 2x plus 3 greater than 0. Then what we do here, if you want to make sure that x is the leading coefficient is positive, then we'll divide everything by negative 1. Then we are going to have x squared minus 2x minus 3 is less than or equal to 0. Remember that when you're dividing by a negative number, what will happen here? You change the direction of an inequality sign. So the direction of an inequality sign, it was greater or equal to. For the fact that we divided by negative, then we changed it to be less than or equal to. Now the leading coefficient is positive, then we can do what? We can get our critical values. As we get our critical values, let's not skip any step. Let's do it step by step. So the minute it gets there, what do? We're looking for our critical values. So it's x squared minus 2x minus 3 is equal to 0. So now we are going to factorize. So we're going to have x and x. The factors of 3 that can give you 2 is 1 and 3. So it's going to be negative 3 plus 1. Therefore, x in this case will be negative 1 or x will be 3. So when we deal with it graphically, it will be negative 1 and 3. Correct? It will be negative 1 and 3, and we apply the very same method where we put x there. So now, remember, when it started, the sign was greater or equal to. But because we wanted to make it positive leading coefficient, we divided by negative, and the sign changed. So this is the sign that we are going to use here now for us to answer our question. Correct? Then what will happen there is that we are going to have 1, negative 1, that is included, and 3, that is included, and then x is less than and x is greater than. So that's how we are going to solve that particular question. So you represent it graphically like that. So it's as easy as ABC. There is no challenge there. So now let's look into the second one. Into the second one, we can see that we have 3x minus x squared greater than 0. So we can put it like this: x squared plus 3x greater than 0. Remember, we're putting in the descending order of x. Then we do the same method. We make sure that our leading coefficient is positive. Then we divide everything by -1. Then negative divided by negative, you get positive, is x squared. Positive divided by negative is negative 3x. Then the sign, the direction changes. As the direction changes, then what do? We get the critical values. So x squared minus 3x is equal to 0. Take out the common factor of x. X minus 3 is equal to 0. Therefore, x is equal to 0, or now x, it will be positive 3. So those are the critical values, correct? Then from our critical values, then what do we do then? We have 0 and positive 3. Then now, because the leading coefficient there is positive and the sign is less than, then we're going to use less than and less than. Correct? Then this is what we want to see. Remember, then represented graphically, we can see that here we have like that. So that's how you represent it graphically. Correct. So grade 11s, please be careful. The minute you want to make it positive, you want to make the leading coefficient positive, you know that always the sign will change. This is less than, not less than or equal to. So that's how you deal with this type of questions. Now let's look at this one. Very interesting question. Very interesting question. So now here, firstly, look into the bracket. There inside the bracket we have 1 minus 2x. Then now you ask yourself, is the leading coefficient of this equation negative or positive? Remember, the leading coefficient, we're looking into the x squared. So now, if ever you have here, you were to multiply here, then you will see that there you are getting what? You are getting negative 2x squared. So now, what can we do in this case? We can simply get rid of negative, but how do we do that? You can say negative 2x plus 1, x plus 3 less than or equal to 0. Then the minute you take out coefficient of negative 1, there you're going to have negative 1 into 2x minus 1, then x plus 3, then less than or equal to. Then in this case, you can see that now I can do what now? I can divide by negative 1. Then negative 1 divided by negative 1, then you have 2x minus 1, then x plus 3 greater or equal to 0. Then from that case, then we can get our what? Our critical values. 2x minus 1, x plus 3 is equal to 0. Then we will have 2x minus 1 is equal to 0, or x plus 3 is equal to 0. So you will find that x is equal to 1 over 2, or x is equal to negative 3. Then what will happen here? You will have your graphics, which is negative 3 and 1 over 2. The very same thing here that we are going to apply. Let's write that one properly there. So it's going to be 1 over 2. Then we put your x value there. Then now we're looking into what? We're looking into this inequality sign now, then we can see that is greater or equal to, or greater or equal to, correct? Then now what are we looking at? We're looking at the shaded that is greater than 1 over 2, and the shaded that is less than 1 over 2. So that's basically how you must solve that one there, correct? So now these are the things that you need to understand, especially when you have the negative leading coefficient and you want to change it to a positive leading coefficient, so that you can apply the method that I have shown you here. So this is how you deal with quadratic inequalities. It's very simple because the answer is like that one there. You leave it here, you leave it here. Most of the learners, they will leave their answers here where it says equal to. Then that's where you, even sometimes you can get 1 mark, because those are just critical values. You haven't answered the question. And let's avoid leaving our answers like this, or we leave the critical values and we claim that those are our answers. Those are not the answers. The answer must be in an inequality form. So I hope that it was clear. So we move forward now. We look into now equations with 2 unknown variables. We call them quadratic simultaneous equations. So with quadratic simultaneous equation, guys, it says quadratic simultaneous equations are 2 or more equations that share variables that are raised to powers of 2, correct? Then we have the 2 pairs now. They're saying this pair of simultaneous equations, there is 1 linear equation and 1 quadratic equation. It's always going to be like this, grade 11, where you have 1 linear equations and 1 quadratic equation. And it further says simultaneous equations involving quadratic can be 0, 1, or 2 solutions because of the way that linear and quadratic graphs can intersect. So now it basically tells us that the minute you have a quadratic graph, the blue graph there, the minute you have this blue graph and you also have this green graph, there are cases whereby it can intersect twice, like this one, it intersecting twice, then you are going to have 2 solutions. There is a point where it can interact once or it doesn't interact at all. So now, let's look at graphically what we are talking about. So, simultaneous linear quadratic equations. 2 solutions is when the graph intersect twice. And 1 solution is only there, then we call it a tangent. Remember, a tangent to a curve, it's only touching once. Then whenever there is no intersection, it means there won't be any solution. So those are quadratic equations there. So now, in the exam, you are going to get equations like this one. There are 4 in activity 3. There are 4 subtopics there. Sub-questions, not topic, sub-questions. So we solve for x and y simultaneously. So let's get into the first one. We are going to solve for x and y simultaneously. In most cases, we are going to look into our linear. Remember, we have a linear and quadratic. We look into our linear because most of the time it is the one that we can either make either x or y the subject of the formula. So in this case, we are looking at the linear equation and we look at, okay, it can only be y that I can make the subject of the formula without stressing out, because remember, most of the learners, they get confused when they dealing with fractions. So if I were to divide by 2 throughout, you can see that automatically you are going to have fractions of 1 over 2 there. So we rather avoid fractions, unless if the question forced us to use fractions. So now we're saying this is equation number 1 and this is equation number 2. Remember, you must label also your equations like that. So from equation number 1, we are having 2x minus y is equal to 1. So one can say, okay, I can simply transpose this one this side, and I transpose this one that side. So we simply gonna have 2x plus 1, which is equal to positive y, and we call it equation number 3. Then you call it equation number 3 like that, because y is now positive. Then what do we do now? We say, okay, if that is the case, then you're going to sub equation 3 into equation 2. Remember, you can't sub equation 3 into equation 1, because equation 3 and equation 1 are the same. We just rearranged the equation there. So what does it mean? It means in equation number 2, where I see y, I will substitute 2x plus 1. So you are going to have x squared minus x into, now it's y, we have 2x plus 1. Then it's equal to 3x minus 3. Then now we can solve for x. Let's rearrange that. We're going to have x squared minus 2x squared minus x. Remember what I've done here? I multiplied by negative x inside the bracket. I just simply removed the bracket. Correct? Then we have, this is equal to 3x minus 3. Right? Then what will happen here is that we add the like terms. We can see that x squared and negative x squared, they are the like terms there. Then we're going to have what? We're going to have negative x squared, because 1 minus 2 is minus 1. Then we have negative x. Now we're doing what? We transpose those ones to the left hand side. Then we're going to have negative 3x and positive 3 is equal to 0. So now, looking at that, we are going to have what? Negative x squared, negative 4x plus 3 is equal to 0. So now, let's try to factorize that one. Remember, we have negative x squared minus 4x plus 3 is equal to 0. So we're looking at that one there. Then we need to do what? We need to solve it. So remember, here we got the first, the equation there. We substituted it there by equation 2. Then we multiplied by, remember, negative x multiplied by 2x is negative 2x, and negative x multiplied by 1 is negative x. So we added the like terms, we transposed positive 3 to the other side, it becomes negative 3, and negative 3 becomes positive. Then we have done it like that. Then what happens here is that we now can use what we call quadratic formula. Remember, you can either factorize or use quadratic formula. So in this case, we know that is x minus, now we're using quadratic formula. Remember, we're solving for x and y. We started with x values there. So it's going to be substitution, -4, -4, -1, 3, -1. So we are going to get the values of x. So now in this case, what will happen is that we get negative into -4 plus the square root of -4 squared minus 4 into -1 and 3 divided by 2 into -1. So you realize that the first one, as you solve it, we are getting -4,65. Then we change it to the second one. The other x value is going to be 0,65. Then from there, remember the question says you must solve for x and y. Already now we're having what? We're having x values. We're having x values. So we need to now get what? We need to get y values. So I'm going to say substitute x into equation number 3. So remember, in equation number 3 we have y, that is 2x plus 1. So, oh, I made a mistake. I made a huge mistake here. We will fix it. I make a huge mistake here. As I was transposing this one, it has to be negative, not positive. That one there is supposed to be negative there. Then there it will be positive. Then there we are going to have positive. Then it's supposed to be -2. Supposed to be -2x. -2x. So that is the mistake that I've done there. Luckily I saw that mistake. Then there we erase it, and it's supposed to be -2x. Let's fix it quickly. -2x. Then also -2x. So -2 and -2. So let's now check with -2. So it's going to be 3. Then when we check the other one, it's going to be 1. It's 1 and -3. So it's -3 and 1. So please be careful. When I was transposing this 1, I put it as positive instead of putting it as -1. So I fixed it, and that's how it is going to look like. So now we can continue by substituting x in equation 3, which is 2x minus 1. So now we're going to have y is equal to 2 minus 3 minus 1. So y is going to be -6 and 1, and is going to be -7. Or we can say y is equal to 2 into 1 minus 1. So it's going to be y is equal to, in this case, is going to be 1. So it means in this case, the line, this linear line and this a quadratic, linear equation and quadratic equation, they intersect in two points. It intersects in 2 points. So please be careful on that one. I've made a mistake there, but we fixed it. So that's how it will look like. Remember, this is how we solve the x and y simultaneously. Okay? We move forward now. We have the second one now. Remember, you always label them equation 1 and equation 2. Correct? You always label them equation 1 and equation 2. So we're saying from equation 1, we are having x plus 2y minus 3 is equal to 0. So here we can work on what? We can work on making x the subject of the formula. So it means everything here will be transposed to the right hand side. So we're going to have x, it's equal to minus 2y plus 3. Then we call it equation 3. So here I hope the signs, we transferred them properly. Positive 2y to negative 2y and negative 3 to positive 3. Then what we do, we say we sub equation 3 into equation 2. You must substitute equation 3 into equation 2. So now what do? We say, okay, we have what? We have y. Remember, where we see x, we put y minus 2 minus 2y plus 3, where we see x. So it's going to be y minus 3. Then here we are going to substitute what? We are going to substitute minus 2y plus 3. Then we move forward to say what? To saying this is equal to minus into squared plus 6. So be careful on that one. We have minus 2y plus 3. Most of the learners, they will omit the squared. Most of the learners, as they are writing this thing, they will omit the squared. But let's refrain from making such mistakes. So now we multiply here. We are going to get what? We are going to get y plus 6y minus 9. This is equal to. Then we have negative there, and we still have 2 brackets that we need to open, plus 6. So we have negative 2y plus 3 and negative 2y plus 3. Then remember, you need to now get rid of those 2 brackets there. So what will happen now is that we add the like terms here. We're going to have 7y minus 9, which is equal to negative. Then we still open the bracket there. We say plus 6. Remember, this negative is outside the bracket. So negative 2y multiplied by negative 2y, you get positive 4y squared. And negative 2y multiplied by 3, we're going to get negative 6y. And then we get another negative 6y, then plus 9. Then remember, when we are done there is still a negative number that needs to be multiplied inside there. Then when we remove that negative number, what will happen? We'll have 7y minus 9, it's equal to minus 4y squared plus, if we add the 2, it's going to be negative 12. Then we can now say it positive 12, then plus, negative 9, not plus, negative 9 negative 9 plus 6. Remember, negative multiplied by 9 is going to be negative 9. And this 6 is at the end there. Then what we do now, we are going to simplify them nicely. Minus 9 is equal to, then we're saying minus 4x squared, minus 4y squared, sorry, plus 12y. Then if you say now minus 9 plus 6, you are going to get negative 3. Then we can now take everything and we transpose it, which is going to be 4y squared, then plus 7y minus 12y minus 9 plus 3 is equal to 0. So now we're going to have 4y squared minus 5y minus 6 is equal to 0. Then now we're going to have our A, B, and C. Then what will happen there? We're going to have y is equal to, then we use our quadratic formula. So what will happen there is that we have negative 5, then we have 4 and negative 6 and 4. Then y will be equal to, or y will be equal to. Then we use our quadratic formula there. So negative 5 plus square root of negative 5 squared minus 4 into 4 and negative 6, 2 into 4. Then you see that the first one there, it will be 2, or we have negative 3 over 4. So those are the two values of y. Then remember, we can substitute y into equation 3. In equation 3, remember our x was negative 2y plus 3. So we have x, which is negative 2, where there is y plus 3. Or it can be x is equal to negative 2 into y plus 3. Remember our y values there. The first one is 2. Then x will be negative 2 multiplied by 2 is negative 4 plus 3 is negative 1. Then now we are going to have negative 3 over 4. So negative 2 into negative 3 over 4 plus 3. Then we are going to get x as 9 over 2. So that's how you solve this type of equation, quotient, correct? Where we have simultaneous equation. So most of the time we'll find that learners will lose marks where you need to simplify, where you multiplying, you removing the bracket, you adding the like terms, you transposing. That's where most of the learners will make mistakes. But in this case, how is this question going to be marked? The first mark there, it will go for the learner to make either x or y the subject of the formula. The second mark, it will go to the correct substitution of equation number 3. Then after you have simplified everything, for you to arrive at this standard form, there is also another mark. And then either you factorize or use quadratic formula, you get another mark there, another mark for the y values, and another mark for the x values. So that's where marks will be allocated in this type of a quotient. Okay? So now let's look at the third one. Now in this case now, there is no need for us to have equation number 3, because we can see that from equation 1 and equation 2. In equation 1, you can see that already y is the subject of the formula. So now you just shoot straight by saying what? By saying substitute equation 1 into equation 2. Then where we see y, we are going to substitute 3x minus 8. So we have x squared minus x into 3x minus 8 plus 3x minus 8 squared is equal to 39. So now we have x squared. When we multiply by negative inside the bracket, we are going to have negative 3x squared plus 8x. Then we have positive 3x minus 8. 3x minus 8 is equal to 39. Remember, 2 squared, we have to open 2 brackets. Then what do we do here? We now remove the bracket. We use FOIL method. Then now we can start now adding the like terms. X squared and minus 3x squared is minus 2x squared plus 8x, right? Then 3 multiplied by 3x, there we're going to have plus 9x squared. Then 3 multiplied by negative 8, then 3 multiplied by negative 8 is supposed to be negative 18, I guess. Or 8 multiplied by 3 is 24, sorry. It will be negative 24x and another negative 24x plus 64 minus 39 is equal to 0. So what I've done there, I just transposed this 39 to the left hand side. So now we're looking into now our like terms. X squared and x squared, they're going to give you 7x squared. It's 9 minus 2. Then we have what? We have 8x minus 24 minus 24. So you have 8 minus 24 minus 24. You are getting minus 40x. Then you go to the last one where you have only 64 minus 39. If you say 64 minus 39, you are getting positive 25. It's equal to 0. So that will be our standard form. Remember, in this case, the only thing that will happen is that you are getting marks on the substitution and the standard form. Then we move forward now. Remember, we have 7x squared minus 40x plus 25 is equal to 0. Then what will happen here is that we have A, B, and C. We can use our quadratic formula. We substitute. We are going to have minus 40, 7 and 25, also 7. Then x will be, or x will be. So now we go and punch in our quadratic formula. Square root of minus 40 squared minus 4 into 7 and 25. 2 into 7. So you get the first one is 5, and the second one will be 5 over 7. The first one is 5 and the other one is 5 over 7. Then we substitute x into equation 1. Remember, in this case, we don't have equation 3. We only have equation 1. So, in equation 1, we have y is equal to, is it 3x minus 8, which is 3x minus 8, or we are going to say y is equal to 3x minus 8. So we substitute there. As we substitute, we are substituting 5 and 5 over 7. So your y will be, or your y will be. So now let's look at that. It's 3 into 5 minus 8, we have 7. Then the other side is 5 over 7. Then we are going to get negative 41 over 7. So that's basically how you solve this type of equation. So remember, in this case, I said you get your mark there, another mark there, then you move, you get another mark there, another mark there, and another mark there. So they can say this type of equation, it can be either 5 or 6 marks. The fourth one, in this case, remember, it's almost the same as the previous one, but we just need to decide now on which variable are we going to make the subject of the formula. So you decide. We can say this is equation 1 and this is equation 2. Then what do we do there? We then say from equation 1, we have y minus x is equal to 3. Then as I take this one to the other side, we're going to have y is equal to x plus 3. Then we call this one equation number 3. Then now, what do we do now? We're going to substitute. We sub equation 3 into equation 2. So equation 3, you can see that we have 3x squared plus x into y is x plus 3 minus x plus 3 squared is equal to minus 3. So that's what we are having there. So we can simply remove the bracket by multiplying by x inside there. Then what will happen? We're going to have 3x squared plus x squared plus 3 minus, then we have to have x plus 3 is equal to negative 3. So this is what you are doing all the time. We open two brackets there, and we need to also use FOIL method to remove those brackets. Then we can see that those are the like terms there. Then what will happen is that we're going to have 4x squared plus 3 minus, then we're still opening the bracket, it's equal to minus 3. Remember, we're opening those brackets because there is a negative that still needs to multiply inside the bracket. So we are having what? We are having x squared plus 6x plus 9. I just added everything together because it will give you x squared plus 3x plus 3x plus 9. So 3x plus 3x is giving you 6. Then we can multiply inside the bracket. Then we're going to have what? 4x squared plus 3 minus x squared minus 6x minus 9 plus 3 is equal to 0. What I did there is to transpose now negative 3 to the left hand side. Then now if we were to put everything in a standard form, we can see that these ones are the like terms. We're going to have 3x squared, then negative 6, yes, is just negative, it's 3x here. It's 3x here. It's 3x there. So is going to be, because this one multiplied by that one is 3x there. Okay, so it's going to be what? It's going to be 3x minus 6, which is going to be minus 3x. Then we have minus 9 plus 3, then it will give you minus 6 is equal to 0. So let's deal with it in this side. 3x squared minus 3x minus 6 is equal to 0. So we can simply see that 3 can be a common factor. Then we can have x squared minus x minus 2 is equal to 0. So now we're looking into that. Either we use quadratic formula or we do what? We factorize. So we're going to have x, then plus 1 minus 2, then x is going to be negative 1, or x is going to be 2. Then from there we substitute x into equation 3, because in this case we had equation number 3. So equation number 3 is y plus y is equal to x plus 3. So y is equal to x plus 3, or y is equal to x plus 3. So we have negative 1 and 2. So y is going to be 2 in this case, and y is going to be 5 in that case. So those are the values of x and y that we were supposed to solve. Then now we look into this type of questions. You can see that as you are dealing with this, you need to be very careful as a learner, because you are dealing with so many terms and multiplication of variables. So you need to be very vigilant when we're dealing with this type of questions. But anyway, you take things step by step and you relax. Okay, so this is the end of the lesson. I hope you have enjoyed this type of a lesson where we're dealing with quadratic inequalities and equations with two unknown variables, which are simultaneous equations. Thank you.